This little V's class, we're learning about probability rules, chapter 15.
Let's do this. Excellent. Thank you. All right. So, the entire 6 problems here have to do with a deck of cards. Now, when I first started taking this course in 2002 as a high school student, back in the days, right? So old, we didn't have smartphones. And our cell phones stayed off in our backpack until we were done with school to call home. All right? I know, crazy! And many of my friends didn't even have phones. So we had to come up with other ways to go through the school day when the teacher said, yeah, cool, study hall. We would play cards. Lots of games. But you may not have the knowledge that students 10 years ago have about cards. So I put some stuff up there. If you don't know anything about cards, there's 52 total. There are 4 suits, 13 of each, 4 suits. Spades, clubs, diamonds, and hearts. Spades and clubs are black. Diamonds and hearts are red. Okay? There are 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, king. Those are called face cards. And then an ace. Okay? That's your card intro, I guess. Let's get into it. So, I draw a card. What is the probability that it's an ace or it's red? So I see that word or, and I think, addition. Or is addition. So, let's go ahead and write down what we know. We want to find the probability that our card is an ace. So I'm going to put an A for ace. Or that it's red. I'm going to put an R for red. You could put the U if you'd like for or. So I'm going to write down the probability that I get an ace plus the probability that I get a red card. Now, if there are 52 cards, how many of them are aces? 4 of them are aces. We have the ace of spades, the ace of clubs, the ace of diamonds, the ace of hearts. There's 4 aces. How many of them are red? Out of 52 total cards, how many are red? 20, not just the aces, but all red cards. There's 13 diamonds, 13 hearts. So that's 26. So based on what we did in chapter 14, the answer will be 30 divided by 52. What is that as a decimal? What is 30 over 52 as a decimal? 0.57. Excellent. That's wrong. 1.5. Oh, wait. Here's why. You ready for this? Are you ready? Are you ready? Are you ready? I don't think you are. I don't think you're ready for the stats. Okay, so in this 4, we have all the aces, which includes the ace of diamonds and the ace of hearts. In this 26, which is red cards, we have the ace of diamonds and the ace of hearts. So we are double counting those cards. So I have to subtract out the probability of getting an ace and a red card. This is that updated version because getting an ace and getting a red card are not disjoint. Right? The reason we were able to do last week A and R, just those together, is because our marbles could not be multiple colors. Our M&Ms cannot be multiple colors. But we have events here that are not disjoint. So we have to subtract out the combination of them. All right? So out of 52 cards, how many are aces and red? 2. We have 2 red aces. So the answer is going to be 28 out of 52. Do you have it? 0.54? 0.538. I like that one better. Does everyone see how this is different, though, than what we did previously? When we had disjoint events, it was more straightforward. So it's a little bit of a curveball here. Okay, let's look at number 2. 2 cards are drawn without replacement. So I pick one up, I look at it. Do I put it back in the stack? No, it says without replacement, so I take it away. So I want to find out what's the probability that I look at a card, it's an ace, put it over here. I look at a card, another ace. So that'd be ace and ace. Very good. All right, well, for the first card, how many total cards are there?
4.
How many total cards are there?
52.
52. That's my denominator. How many aces are there to start?
4.
4. Everybody good on that? So when I pick up the first card, I've got a 4 out of 52 chance it's an ace. But now I'm telling you it's what? It's an ace. And I take it away. So now, how many cards do I have left? 51. And how many are aces? 3. Very good. So what is that as a decimal? 4 over 52 times 3 over 51.
.004.
Confirmed?
Yeah. 0.005.
Should we round to 5?
Yeah.
All right. Sorry, Yasmin. All right. So, is it likely that we'll get an ace, put it aside, and get another ace right after?
No.
No. Right? And that's what that says. It's less than 1% chance. Less than 1% chance that we'll get an ace and then another ace. All right. Let's do number 3. Number 3 says I draw one card, I look at it, and I tell you it's red. If I tell you it's red, what's the likelihood that it's a heart? Now, this is an example of what we call a conditional probability. Okay? So, I want to find the probability that I get a heart. Not a great one. That's okay. So what's the likelihood that I get a heart? But I'm already telling you what about the card? I'm telling you it's red. So see how that goes after that conditional bar. So let's think. How many red cards are out there?
26.
26, because we have 13 diamonds and we have 13 hearts. So if I tell you it's red, what's the likelihood that it's a heart? 13, so we have 13 hearts. So it's going to be 0.5. Very good. That's it for that one. But now I'm changing it up. Now I'm saying, if I tell you it's a heart, what's the probability that it's red? So now I'm going to find, if I tell you it's a heart, what's the probability that it's red? Well, how many hearts do we have? 13 hearts. How many of those are red? 13. So if I tell you it's a heart, and I ask you what's the likelihood that it's also red, the answer is always 100%.
Does that make sense?
Let's see. If I hold up a card, and you ask me, hey, what can you tell me about it? And I say, it's a heart. And then I say, what's the likelihood that it's also red? We don't have any black hearts. We only have red hearts.
Oh.
So if I tell you it's a heart, and you ask me, well, what's the likelihood that it's also red? It has to be red.
That's how
100.
they're different, right?
Say it again?
That's how the person's in the first.
Yeah, so the first one, so what students usually think when I teach this is because the order has changed, they think, oh, it's just the reciprocal. But that didn't happen, okay? That does not work. So don't go down that road. Okay, I'm going to go to the next one. Number 4. Now, all 3 of these are asking the same 2 questions. Are these events independent? And are they disjoint or mutually exclusive? Okay, so let's just real quick think about, what does that mean? What does independent mean when I talk about two events being independent? Great. One happens. What happens to the probability of the other happening? Unaffected, nothing. What about disjoint events? One happens. What happens to the other one? It can't happen. Very good. The probability goes to 0. All right, I love it. All right, so let's do it. When I do these problems, I pick one to focus on. Red card and spade, those are my two events. I don't care which one you want to focus on. Spade, very good. So we're into the probability that we get a spade. Well, how many cards are there? 52. How many of those 52 are spades? 13. Very good. What is 13 out of 52? 1/4. So 0.25. Everybody feel good? Now, here's where it gets a little confusing. I still care about getting a spade. But now I want to tell you something else has already happened. So I'm going to put given that I have a red card. Now, here's what I'm saying. Now I tell you the card's red. What's the likelihood that it's a spade? If this is the same, if it's 0.25 as well, then they're independent. Okay? Let's see what happens. How many red cards do we have? How many red cards do we have? 26. Out of those 26 red cards, how many are spades? 0. None of them. So 0. So let me ask you this. Did the probabilities stay the same? No. So these are not independent. Red card and spade are not independent. Questions on that? So the reason they're not independent is because the probabilities are different. Now, what is really important that I see here is not only did the probability change, it went to 0. So that tells me they're not independent, but they are disjoint or mutually exclusive. And think of it like this. If they're not mutually exclusive, we should have some red cards that are spades. But do you know of any red cards that are spades? No, we can't have both. If I tell you it's a spade, it can't be red. If I tell you if it's red, it can't be a spade. All right? They'll never happen simultaneously, so they are disjoint. Everybody good? Okay. All right, let's keep going. The next one says, same thing with red card, but now red card and ace. So which one do you want to focus on? Doesn't matter. Ace. All right, how many cards do we have? 52. How many of those are aces? 4. So what is that as a decimal? What is 1/13 as a decimal? So 0.077? Perfect. Okay. Now, I'm focusing still on ace. But what is the condition now that I'm telling you about the card I'm holding up? That it's red. So I pick up a card and I say, hey, it's red. So how many red cards do we have? How many red cards do we have? 26. Out of those 26 red cards, how many are aces? 2. What is that as a decimal? Ah! They're independent. Because the probabilities did not change, they are independent events. Now let's see if they're disjoint. If they're disjoint, I can't have either of those occur simultaneously. So if I tell you it's red, it can't be an ace. If I tell you it's an ace, it can't be red. They're not disjoint because we have 2 red aces. Right? So not disjoint. All right, our last one. Now again, as a reminder, face card is like jacks, queens, and kings. Those are face cards. They have faces on them. Okay? Now, the first two you've picked the second event to focus on. So can I pick the first one so I can show you that it doesn't matter? It doesn't matter what order. Okay. So let's start with face card. So how many cards do we have? 52. How many are face cards? Well, there's jacks, queens, and kings, but there's one of each suit. So there's 4 jacks, 4 queens, 4 kings. So that's 12. So what is 12 over 52 as a decimal?
0.231.
0.231? Confirm, anyone?
Yes.
Excellent. All right. So I'm still focused on face card. But now what's my conditional? That it's a king. How many kings exist? 4 kings. If I tell you it's a king, what's the likelihood that it's a face card? 100%. Because all 4 kings are what? Face cards. So 100% or 1. Are they independent? No. They're not independent because the decimals changed. Are they disjoint?
No.
If they're disjoint, that means if I have a king, then it can't be a face card. If I have a face card, it can't be a king.
Yes, they are. No,
No, because all kings
Our face.
are face cards. So these events are also not disjoint. What? So they're not independent, and they're not disjoint. Now many students ask, well then what is it? They're just events. They're just events that are not independent and not disjoint. There's no. Ooh, good question. Guess we'll find out.
Bye.
Wow. Don't forget to like, subscribe, click the bell so that way you can get notifications. All right. Please subscribe. I'm really close to 100, really close to 96.